Good afternoon, everyone. It's a real pleasure to be here and talking to you all. As Colin has just said, my name is Jonathan Bray. I'm the Vice President of the PWI and also the Head of Infrastructure at the Docklands Light Railway, working for Keolis Amy Docklands. I've got with me this afternoon Tom Mann, who's our track manager at Keolis Amy. I'm just going to, and we're going to talk about the engineering and evolution of Docklands. I'm going to turn my camera off, one, so it's not so distracting, and two, hopefully it'll improve the bandwidth and sound. So I'll do that now. Okay, so a little bit about the Docklands Light Railway. I can move the slide on. There we go. So just some headline numbers for you there. I mean, it's a railway that's been going about sort of just over 30 years. Started from humble beginnings to where we are now, and it's worth just mentioning that we're probably in the top 10 in terms of railway operations in the country, in terms of passengers carried. As you see at the bottom left-hand corner there, over 400,000 passengers, on any weekday. That was pre-COVID, and we're getting back up to those numbers now since COVID. Some things to also note is it's a fully automated system, completely automatic. If you go on the front of the train, there's no drivers, but we do have a member of staff on every train that can sort of step in if need be. Two main centres of operation, Beckton and Poplar. The story of the DLR has been one of sort of growth, really, and very much the development of this part of London. You can see from the pictures along the top, the network has grown in stages, and we'll talk a little bit about that more during the presentation, and also changes in rolling stock. It played a big part in 2012 when it was the Olympics, and a lot of the Olympics were centred in this area around Stratford and Greenwich and so on. And it was very much the games of public infrastructure, public transport. And it's a key thing. You build the infrastructure, you build the public transport, and that then aids development. And this area of London was quite depressed in terms of a change of industry, and the pictures at the bottom show you the sort of transformation that's been happening slowly in this area. So two pictures about 10 years apart, but the same view, but obviously very different how it's looking today. And this map sort of puts that into sort of geographic terms, very much part of the Mayor's development plan. As I say, making good use of former industrial areas like the Isle of Dogs and various other Dockland areas and industrial sites, and a lot of new homes and sorts of small industries that go with that. So it's very much a growth railway. And just to finish off with that, again, another two pictures which show the same view, again, roughly 10 years apart between them, but it shows what happens. You put the transport infrastructure in place first, and that then, is the sort of driver for development. So all that by way of introduction. What I'm going to do now is hand over to Tom Mann, who is the track manager, to introduce himself and also take you through some of the engineering for the network.
Okay, hello, good afternoon, everybody. My name's Tom Mann. I'm the track manager for, Jonathan said, Docklands Light Railway. We actually work for a company called Keolis Amy Docklands, who are a contractor that maintain the Docklands Light Railway, but more of that later. I've been here probably far too long, but 15 years on the DLR as the track manager. Previous to that, spent my career mainly in London Underground in track positions. So when Jonathan talk about engineering, we will touch on signals and rolling stock, but most of that presentation will be around the track assets, how we maintain the track on the DLR. So I remember when I first came over to work for DLR, people said, "You're going to go and work for that Mickey Mouse Railway, are you?" And that was quite a common name for it in those days. And I suppose when the railway first started off in 1987, it was probably known as a bit of a Mickey Mouse Railway. You know, was it a proper railway? The way it started was back in 1987 then, just a one-car train of what was called the P86, 89 stock light rail vehicle, very low-key development. That's actually a picture of West India Quay that you probably wouldn't recognise today. The railway moved on to a two-car setup with the B92 stock. I suppose you could call that beginnings of a train. And then again, just after I came here in about 2008, 2009, we had the free car upgrade, and that's where you got free cars, free light rail units, B2007 stock, and I suppose you could actually call that a proper train now, and a proper railway with all the extensions that occurred. And then the future, tomorrow, if I can get this to work, we have a new stock arriving on the DLR, and I'm just trying to find the video. There you go. One's the technology. So this is our new train. We've got 3 of them already delivered in Beckton Depot. Completely different. Its appearance. It's instead of like a 2-car articulated unit, it's actually a 5-car fixed full. So DLR, the ever-growing railway really. When it was first opened, it was only 13 kilometres. It's now 40 kilometres in routes. You can see that the number of passenger journeys have gone up from 8.2 million to around 122 million around the time of the Olympics and after that. And even now, post-COVID, we've recovered to about 95 million in 2020. That soon. And the original railway was built just as a design and build project, and I think it was very much a case of the cheapest bidder with 77 million to build the original railway. It's the UK's first fully step-free accessible railway for wheelchair users. We now have the Elizabeth line interchanges, and over the years there's been lots more talk about even further extensions, but the one that seems to be in the news at the moment is another branch under the River Thames across to Thamesmead. So that was the original railway. 3 branches: South Route, West Route, North Route. And within a couple of years of that, the tunnel to Bank and the city extension had been built. And those were the days of the 1-car unit. And then the extensions just come thick and fast since then. So after Bank, we had the Beckton extension in the east. We had the Lewisham extension under the river in the south. We then had the London City Airport Woolwich extension. Finally, prior to the Olympics, 2011, we had the extension up to Stratford International extension. And for my career with this, inherited the Stratford International extension. And Cody Samey now, as the contractor that maintains the railway. Previously, some parts of the railway were maintained by concessionaires, but now we actually maintain and operate the whole of the railway, as seen in that map. And again, just to look at a bit of history, to add on to some of the pictures that Jonathan showed earlier, that was Docklands in 1987. I don't know if people can see the cursor, but that little dot there, that is Canary Wharf. Docklands at that time was supposed to be a low-rise development. And here's our railway. And myself and Jonathan are sitting in this building over here presently, which is still there. And this is the railway crossing the docks, going south, round past what was in the London Arena, down towards Island Gardens, west towards Bank that way, and across to the east and the north routes this side. And then if you look at Canary Wharf these days, for those that have visited, this is basically looking out from the window from where we're working at the moment. This is that dock now. You can see how that's been developed, and you can imagine the number of people that brings into the area. Just another example of expansion. That's Beckton Depot. That's our largest depot. We've got 2 depots, Beckton and Poplar. Sidings in the south were an extension that were installed for the free car upgrade. But for the new trains that we've got coming, 43 new trains that are coming, that's what's going to happen to Beckton Depot, and a lot of that work is in progress at the moment. So we have this total expansion of the north sidings. We've got an expansion of the south sidings. We've got new maintenance buildings. We've got new fans going in. We've got new test tracks going in. So this railway, never seems to stop growing. So as I said earlier, Docklands are a contractor. We're not part of TfL. People think we are, but actually we're not. We're a contractor to TfL. TfL are our client organisation under the Mayor of London, and there is a client organisation known as Docklands Light Railway Limited. They own all the assets. They are the infrastructure manager and controller under ROGS. We won a franchise for 7 years from December 9th, 2014. And since then, we've had that extended a couple of times up till March 2025. And there's a re-tendering exercise in progress at the moment. So CAD, as we call ourselves, we operate the railway, we maintain all the rolling stock and all the infrastructure assets in like a sort of vertical integrated railway operating system. There's a client shadow organisation for assurance within DLR, and also DLR do all the capital replacement and upgrade projects. We just do the maintain. That said, we do contribute to proposals for assets that need replacement. So the franchise agreement is a contract. I'm not going to go through all of this. In terms of the contract itself, there's a franchise agreement, which is a massive legal document, and schedules, and we have standards within the DLR standards specific to the DLR. We have our own procedures within CAD and our own maintenance task instructions. That said, these standards and procedures aren't very extensive. So a lot of the time, what we do, we actually, particularly in the track area, we actually end up referring back to Network Rail and using Network Rail or London Underground standards. So we are constantly referring to a whole mass of different standards. Sometimes we even go back to first principles, basics, bring in consultants as required. Again, I'm not going to dwell through all of that, but I think the point to be made is for the original railway and for all the extensions and upgrades, it's always been done here on a design and build construction contract basis. So it's not about TfL providing their standards, it's about the prime contractor consultants offering proposals and then them being accepted or otherwise. Just a few standards in terms of the track. So our gauge is 1435 mil throughout. We don't have any gauge widening on the curves, despite them being very tight. We come down to a horizontal radius of 40 metres, which is quite tight in railway terms. Cant's more or less the same in terms of maximum cant as the mainline railway. Cant gradients come down to 1 in 200. And our vertical gradient, we go up to 6% on our vertical gradients, which causes us some problems, particularly when we want to bring in engineers' vehicles. It's unlikely that you can find engineers' vehicles that can actually work on a 6% gradient. We have check rails on horizontal curves of less than 75 metres or less, and all our slab track is covered with derailment outguards. And just to give you an idea, there's a couple of alignment drawings there. The top one's one of the drawings for the original Railway West route, and the bottom one in more detail is an example from the Stratford International extension. Track components and metrics. Most of the route we've got on the system is ATA flat bottom section. We do have some 113A flat bottom because we have some ex-British rail lines between Shadwell Limehouse, which actually the track bed is probably the original Fenchurch Street British rail track from that time. And also the Stratford International branch, because that used to be part of the North London line. And we have a new diversionary route due to Crossrail. Well, some people think it was built for the ABBA concert hall, but a lot of that is in the 113A track as well. Just as a point to note, it is our client's strategy now going forward that any extensions or any significant upgrades will be delivered in 113A flat bottom rail and not ATA flat bottom rail. We have head hardened rail or high performance rail on the tight curves. We're totally CWR apart from around S&C. S&C isn't stressed, so it's all protected with adjustment switches. Inclined on the plain line, vertical rail on the S&C, and where we have check curves, we have all UIC 33 check rails. Spoke earlier about some of the route metrages. So we've got 80 kilometres of single track. It's about 50-50 ballasted track, slab track. 2 depots. I've shown you the picture of Beckton. 130 mainline point ends. So though it's a relatively small railway, it's quite a high concentration of S&C and about 326 adjustment switches and structural expansion switches of various types. So lots of discontinuities throughout the system. Just a quick look at the 2 different rail sections. I'll use the old terminology for them. So the ATA rail, what's the difference? The web is slightly less. The foot width is smaller, and the railhead itself is smaller as well. But that's quite a good picture that demonstrates the differences between the 2 rail sections. Just an overview of different types of track. 50, like I say, 50% slab, 50% ballast. And I won't spend a lot of time talking about ballasted track on the DLR because it's very much the same as ballasted track on other railways. But just looking at the picture, a couple of things to notice maybe is our signalling system. So that's our loop cable that goes down to 4 foot. And we've also got a loop cable that goes along the web just on the foot of the rail there, if you can see it as well. That's basically the transmission-based signalling system. And our conductor rail, which is, isn't like the network rail, it's an underside pickup contact system. And again, we'll talk a bit more about that later on. So I thought to focus a bit more on slab track because, as I say, that's the difference between probably this railway and lots of other mainline railways. When we started with slab track, it was just a simple SG base plate with a hard grout pad with holding down bolts directly fixed to the track slab. And that track form has served us well. We've still got a lot of track with that track form that we hardly touch in terms of maintenance. But as the railway got older and upgrades were added, started to investigate resilience for slab track resilient base plate assemblies. And this was some really early resilient base plate designs that came from Pandrol, whereby there was a dimple pad actually put under the base plate. And this then progressed to the East Route and bank extensions, where the SG base plate was mounted onto a 20mm resilient Tyflex pad. And then we had the major expansion at Canary Wharf. People building Canary Wharf at the time, Olympia and York wanted the best track system to keep noise and vibration to absolute minimum, and actually funded what they thought was the best resilient base plate at the time, which was this cloth egg, where there's actually like a rubber sandwich between the top casting and the bottom casting, made by a company called Clough in Germany, and were used in tramway in Cologne, and hence the nickname, the Cologne egg. And you know, to this day, those base plates are still performing 30 years later without any maintenance, any intervention, and still performing well in Canary Wharf. And then some of the more modern Pandrol designs on some of the extensions, we've had the Pandrol Viper and also the Pandrol Vanguard, where the rail is actually supported rather than supported by the foot. The rail is actually suspended by two rubber blocks that are compressed into the rail web. That's the system shown on the right-hand side there. And then last but not least, more recently, where we've actually undertaken base plate renewal on the system, we've gone over to a Delcor base plate, which is a development of the original Clough base plate. In fact, Delcor sort of bought the rights to that system. And for a lot of our slab track that had those resilient pads underneath, we're now relaying that slab track with these Delcor base plates on the slab track. Bank tunnel, just as out of interest, again, mainly sleepers, concrete sleepers cast into the concrete invert. But interestingly, you haven't got shoulders. You've actually got these resilient base plates again mounted on the sleepers. And we've also, in one section of bank tunnel, we've got some resilient boots that are installed under 50-metre section due to the sensitivity of the building up above. Lots of other stuff is very much the way you will be on the normal railway. That's an adjustment switch, but it's 80A rail instead of 113A rail. Something a little bit unique to the DLR is on our viaducts, where the structure moves, we have to allow for the structural movement. And we have something called a structural expansion joint in the rail, which is very much like a stock and switch arrangement, which provides for more movement than a normal like an adjustment scarf blade would provide for. For S&C, we have our own design of S&C, so we don't adopt the Network Rail standards, REPW designs, which we tend to call by the radius of the turnout. So we have 40 metre, 100 metre, 245 and 341 metre radii. As I said earlier, it's all vertical, and that can be direct fix on the slab. It can be resilient on the slab. We've got S&C on Cologne type base plates. And where we've got ballast, we've either got timber or more recently, like the installation, the photograph there. That's actually on composite bearers at Canning Town. Originally, the railway was all semi-welded crossings, but for the upgrades, and more recently, we've gone over to cast crossings with weldable legs at TMZ. As I said earlier, all protected by adjustment switches, and the signalling mechanism on the main line are all HW clamp lock hydraulic layouts. Bit difficult to see that, but that's just trying to demonstrate that these are our unique turnout geometry for DLR, which again is we use the name that we use is all around the radius of the turnout. Just a few examples of some tight turnouts there. You've got first one is a 40 metre radius turnout on ballast. We've then got the 40 metre radius double junction diamond up at West India Quay on slab, and then there's a 100 metre radius turnout there at Royal Mint Street on slab as well. Just a quick look at the types of crossings. Semi-welded crossings were on the original railway. They're almost nearly all phased out now, and we've gone for cast crossings. And then up at Canary, once again, the developers wanted the quietest railway they could get, so they actually paid at the time to install swing nose crossings up there, and cast swing nose crossings we used based on the design on Glasgow Underground. The irony is now, but actually, as part of our renewals programme now, we're now removing these because of the unreliability of the signalling equipment with the swing nose crossings. We don't have any trackside lubrication of the running edge of the rail. The only lubrication we have trackside is for the check rail, and that shows a computer-controlled automatic spreader plate on the check. And for the wheel contact, we have a stick glue type arrangement on the trains, which is interesting because with the new rolling stock, we're going to have a spray lubricant on the wheel of the train. So that will be interesting to see what that does to the wheel rail interface. Our conductor rail, again, completely different to anywhere else. Bracknell-Willis system, 750 volts DC, with a high conductivity aluminium body. There's a 5mm stainless steel cap on it that is the contact. Shrouded on top with negative return for the running rails. This is a system that's, again, unique to DLR, although this type of Conrail arrangement is used on other railways. But again, we've just been hit with like a message of obsolescence, because we've been advised that Bracknell-Willis, that actually own the intellectual property rights, make all of this conductor rail, have decided that they're no longer going to produce this conductor rail. I think London Underground have got a similar issue with that. So currently, we've just started looking at how we're going to manage that, how we're going to find another supplier when our spares run out. So in terms of signals and rolling stock, Jonathan spoke earlier about the moving block transition-based signalling system, which is now under Talis, under contract to DLR. The great thing about that for me, especially coming off the London Underground, is that there's no block joints, there's no insulated rail joints apart from the depots. So again, we've got the constant concern of block joint failures. But we do have loop cable, and we also have axle counters to back up the system as well. As I said earlier, all the S&C is hydraulic clamp lock mechanism. And again, just a summary there of the stock, and you can see the two types of stock there on two of the viaducts at West India Quay. We run at a top speed of 80 kph, with although it's called a light railway, the 10-ton axle loading is similar actually to some of the tube stock. So although it's called light, it isn't actually that light. This is just a look at our new trains that are coming. As I said earlier, totally different. You've got a 5-car complete unit, and in keeping with lots of modern rolling stock these days, you can actually walk all the way through it. Haven't had the pleasure of actually travelling on one yet, but that's something we're looking forward to. So how do we deliver all the work? We have a track team of internal track team of 40 staff. They all work permanent nights, and we've got a small day support team. We undertake all the inspection, maintenance, all the type of stuff that you normally would do on the railway, from track patrols, supervisory inspections, through to all the S&C inspections, and all the conductor rail inspections as well. We see the conductor rail as part of track here. Unusually for a PWI team or a track team, these guys also undertake all the protection duties and the ETE duties. So they will do the bonding, they do the conductor rail connections, they also do operation of isolators, and even more unusually, we operate the engineers' trains that we've got. So these guys this team will actually load the trains, unload the trains, marshal the trains, and drive the trains to site, as well as operate the HIABs and the RRVs that we've got. We also do all our training and assessment in-house, all our planning and engineering support, and also all our materials and spares management. We don't have a separate materials department. We do that all within our own team, engaging with external suppliers. There's lots of stuff that we don't do that we bring in, the specialists. So stuff like ultrasonics, eddy current testing, geometry recording, all that type of stuff we actually put out to contract. So I mentioned earlier our engineering vehicle fleet, and these are our little toys, our yellow toys, our internal toys, which for some reason some of them have gained names over the years. So we have our RRV, which is again it's operated. All these are operated by our own internal team. RRV. We have a battery loco, which enabled us to go down tunnels with trains. For whatever reason, has been nicknamed named Kylie. We have our CT30, which was actually involved in building the original railway in 1987, as was the GC locomotive, and we have a selection of wagons. So we're all sort of fully self-sufficient in terms of getting materials and plant out to site. For Big Yellow Plant, we don't own any of that internally. We actually go out to and buy that in as a service. So for years we've brought in the Plus 08s. Used to be from a company called Zwiebau in Germany, and more recently we've used the Volker Rail Tampa. The biggest issue we get with engineers' vehicles is the clearance to the conductor rail. And even at present, even with the Volker Rail machine, where we've done a renewal, we've had to remove the conductor rail to enable it to do the finishing tapping on that job. And then for railhead treatment, again, we buy the service in. We used to do a lot of rail grinding, and we can see the Zwiebau machine on the right there. But over the last 2 or 3 years, we've moved over to rail grinding. Rail milling, using a Limag with a Lissinger machine. We buy the service in, and we get extended engineering hours for 2 to 4 weeks a year. And then we plan to treat all our rail corrugation sites, RCF sites. And we found that far more productive, and also the finished job we think is of a far higher quality. Like any other railway, we have our annual inspection and maintenance plan. Again, I'm not going to go through all of the stuff that we undertake. So we do all our seasonal maintenance, we do all our inspections, and again, all our corrective works. And to manage all of that, we have an asset management system known as DLR Metro, based on LU's tube line system. It's an IBM Maximo-based system. It's used by all asset disciplines. It's used a bit differently by track because we manage a linear asset, and then we use the TfL location coding system to locate our linear assets, which means rather than have mileage as they used on Network Rail, where you go from 0 to 50 miles, we actually have chainage or mileage on a station-to-station basis in the direction of running, which is a bit of a different system. But that all feeds into the DLR Metro system. We've also used mobile devices for things like track patrols, some of the SNC inspections, that then put the data straight into the Metro system. And this is all currently, we've got an upgrade in progress at the moment, and that should all be delivered by the end of April this year. So how do we get to do the work? So we get engineering hours at night. We don't do anything during traffic hours or daytime. So that would mean we don't do any in red zone working in Network Rail terms. Everything's under isolation. Everything's under possession. But we only get very limited access hours at night. Tuesday to Saturday morning, we only get 1:30 to 4:30 on paper, but that could work out to be 2.5 hours, a little bit more at the weekends. We also get weekend maintenance possessions. We get 52-hour possession of each route. So how we manage that is if we're going to bring in a big yellow machine, or if we're going to do a lot of corrective maintenance, we tend to save that for the maintenance possessions. I'm afraid that your Network Rail track safety certification won't get you on the DLR. We have our own safety certification. We have our own, what we call the DLR track awareness and DLR PICAL, and we manage all of that through Sentinel on the railway as well. And that's just an example of the planning sheet for, you know, it's quite basic, but it works. We have a weekly possession meeting. If you want to get access to the railway, you make sure you go to the possession meeting and you make sure you get your areas booked. And basically that diagram, all that shows is the different isolation areas and which departments have actually got them booked in. And the green bits are all shown as isolated and the red are as alive. So that's how it's done. Just final few words about asset condition and performance. Tend to get a very low level of rail defects on the railway. That could be related to the axle loading. And we get a very low level of track-related operational performance incidents as well. A bit worryingly at the moment, over the last 2 to 3 years, the number of broken rails have been increasing, but that seems to be related to specific types of rail, like TMZs on cast crossings. Generally, our track geometry is quite good. We don't suffer from, you know, poor ballast conditions or wet beds, and we don't have any TSRs in place because of that at present. What we do find we get is a very high level of railhead wear and aggressive railhead as well, wear and RCF. Some of the issues we do get with the slab track, people might think that slab track's maintenance free. It's not maintenance free, particularly on some of the older designs where we suffered with broken holding down bolts and wide gauge. Like any other railway, we suffer with stop rail stub bolt failures and something called poor ride quality due to something called asymmetric railhead wear, which I'll show a photo of in a moment. We also get railhead corrugation. We suffer with rolling contact fatigue, but we manage that through regular eddy current testing and grinding. As I mentioned earlier, we have suffered with TMZ failures on cast crossings. And more recently, adjustment switch blade breakages, some to do with voiding, but also some to do with what we found where we get depressions on the actual blade itself, creating a battering effect. So just a few pictures of some of those. This is the wide gauge and the defective holding down bolts issues we had. Basically, what's happened there is we get fatigue on the holding down bolt because of the amount of times it's stressed and bent due to the resilient pad. I mean, the ultimate answer of this has been to actually relay this slab track in a different track form, and that's where the Delcor base plates have been used. Just to note that any track renewals are undertaken by TfL, our client, Docklands Light Railway, as a project. We only actually do the maintenance. So for these particular sites, we proposed the fact that we believe this needed renewing and that we needed a different track form design. Just a few pictures there. Railhead condition, I told you that we do suffer from quite aggressive railhead wear. So this corrugation there on one of our tight 40 metre curves and RCF. And I don't know how clear it is on the photos, but we suffer from a railhead condition called asymmetric wear, where the wear pattern over a wavelength of about 10 metres sways from one railhead to the other side on straight track. And this is progressive, and ultimately it results in the ride quality of the train becoming very poor, almost like a hunting. You can see it better probably in this photo. You can see that the wear on the rail is this side, and then it transfers to the other side. So the only way we've managed to sort of deal with all of these, the answer to this at the moment is our rail milling campaign. You know, we can probably remove most of those railhead conditions in 2 passes, which is a massive improvement as when we used to do the rail grinding, when to remove corrugation like this, we might be up there doing up to 30 passes to remove it. So rail milling has been a real success for us in managing these railhead conditions. And then finally, just the cast crossings. I don't know if it's something that's unique to DLR. I have asked around other railway colleagues if they've suffered with similar issues. We did have a spate about 2-3 years ago of cast crossings on a particular, and again, they were on a particular batch of a particular supplier of TMZs failing and breaking. Again, we investigated into the causes of these and found that a lot of them were related again with railhead depression locally over the actual TMZ itself. And so now we've actually brought in some intervention whereby we do a further inspection of these rail, check under the foot of the rail for any cracks, and actually check the batter on the railhead as well. And then we can either grind out the depression, or we can change the actual crossing in the TMZ before it gets to a full failure. Okay. So, sorry, a bit of a quick run through of what goes on the DLR. So, if there's any questions, or Jonathan, if you know anything to it.
Thank you for that, Tom. And yeah, we'll throw it open to the floor now for any questions.
Yes, one from me actually. Can you hear me?
Yeah.
A couple of things sort of jump out at me. I'm sure you thought about. One is the asymmetric wear. Have you tried? Because I think it was ballasted track in the photo. Have you tried lowering the cant to increase cant efficiency so you get better steering of the bogies around the curves? Have you tried that one?
We most of the asymmetric wear we actually get on straight track.
I was on straight.
Yeah, oh, yeah, and we get it mainly on straight track and on the shallow curves. And
yeah.
one of the
okay, forget that then.
Yeah, no, but just out of interest though, before my time, as I understand it, on the North route, they did actually do a trial of putting I know you shouldn't do it, but they did put a 5 or 10 mil cant on the straight to see if it stopped the asymmetric wear returning. But it didn't seem to make a lot of difference, to be honest. Yeah.
No, no. On the straight, I think you're going to get hunting if the vehicle wants to find a room, it will. You're going to get that. But the other one I was thinking about was the you mentioned stub bolt failures on stock rail, and have you thought about having shallow depth S&C instead of full depth so you can eliminate the stub bolts?
It is something that's been thought about, but unfortunately, we don't undertake the renewals. We don't scope out the S&C.
So
it's really something for our client, and it is something that we have sort of suggested to our client that they to look at the design of the base plates.
Yeah. Okay. All right. That's great. Yeah. Thanks, Tom. Yeah. Cheers. Pass to somebody else. Yeah.
Yeah, I'll go. Yeah, Jonathan, I don't know whether you can see as well, but you've got a few questions in the chat. But if I just ask mine. So it's very interesting to listen about the highly skilled teams of people that you've got to undertake the maintenance work. And I was just wondering, does that mean then that those teams tend to stay together longer because they have, I guess, greater variety in their work? And also, do you run any kind of sort of an apprenticeship type scheme for a young person who maybe wants to go and join that group?
Yeah, I mean, in answer to the first question, most definitely. I mean, it is a varied thing, and I mean, as Tom mentioned, I mean, the fact that some of them work the engineering vehicles and also look after some of the possession stuff, that in itself means that we sometimes, or quite well, we're part of the support when renewals work is done as well. So that keeps it varied and interesting. in terms of the work. And I think it's fair to say that you know, our turnover of staff maybe not as high as some areas. So you know, I think that I'd like to think that goes to show a level of job satisfaction and you know, the sort of what goes with that. Also, we have things like we have a point care team. So you know, there's one of the benefits of we're a relatively small organisation is you end up working very closely with the other asset disciplines, whether it's the power side, whether it's the rolling stock side, or indeed the signal side. So we've got like a point care team, and again, people move between that. So it's wider than maybe what you might think of than a conventional track maintenance team. So that definitely all helps with that. The other thing about apprentices, we don't have any apprentice schemes at the moment. We have had previously, but again, one of the you know, there's benefits of being a small organisation, but one of the downsides is some of those bigger training opportunities, you know, don't work out so much with that. Does that answer your question, Jane?
Yes, absolutely. Yeah. Thank you very much. Thank you. Very good presentation. Thank you.
Thank you.
Jonathan, do you see those questions in the chat?
If somebody can maybe read out some of the questions in the chat, Phil.
I'll read them out, no problem. I'll deal with Will's question first, and then Malcolm after that. Malcolm's got a couple. So Will's asking, is this 5-car train the same length as the previous 4-car vehicles, or have platforms been extended to accommodate the longer trains?
It's the same. It's the same length. Yeah, the size of the actual coaches themselves, the 5 coaches, is slightly different to the existing. Where we run what we term the 3-car units, each car is in fact 2 coaches articulated together. So in effect, it's almost like 6 coaches, albeit they're small. So no, the trains are an equivalent length. But as Tom indicated with the walkthrough style of the interior, the capacity does increase with that.
Okay. So no platform extensions.
No platform extensions. No.
Okay. Thank you.
It's a good question, because they were done. Because when originally the railway was built, it was built as a 1-car system with the option of extending to 2. And then as you saw all of the development works, about 10-15 years ago, the decision was made to increase to 3-car, so the sort of 3 sets of articulated pairs, and that did require extensive platform extensions as part of that work.
Yeah. Okay. All right. And Malcolm has got a question. How do you manage adhesion on DLR?
Okay, I'll pass you to Tom.
Yeah.
I swear that one. Go on, Tom.
How do we manage adhesion? Because we're an ATO system, we do actually suffer from what we call non-communicating trains a lot in what we call the NC slipslide season, which is like late October through to end of December. And I mean, I wouldn't call it, lack of adhesion like you might see on the big railway. We see trains go for long distances, due to poor railhead condition or anything like that. But it's because if you get any type of slippage on the wheel rail interface, the computer on the train basically won't know where it is and just shuts the train down. And that's what we call a non-communicating train. So our main line of defence against that at the moment is, because we don't have drivers, on the signalling system, we actually implement what we call something called an overlay, which will put in go slow zones or TSRs in place to try and control the way that the vehicle is braking. So we try and do it through the signalling system more than anything physically on the track. That said, we have got 8 traction applicators sited on the network as sort of a belt and braces backup. If we found that over time that we weren't getting the results required using the signalling overlays.
Okay. Colin Smith McLeod has got a question. This is related to the previous one, isn't it? Do you know how the cause of possible hunting issue on straight track, and have you tried anything to reduce it? You mentioned that before, right? I don't know, is there anything else to add?
No, I think Tom mentioned that they tried putting some cans on the straight as a thing, but as I think it was either Phil or another gentleman remarked, on straights it's more difficult, and if you get any sort of discontinuity, that would be enough to upset the balance and then start causing the trains to hunt, to oscillate, and once that is set in, you're on the it just slowly gets worse over time.
Sure. Okay. And Stephen Long's got a question with the contract setup, creating a potential conflict of needs. How have you reached a wheel rail interface strategy between you and the clients? Yeah, I suppose is this, I think, if I read this correctly, Stephen, this is more about if you know that your client is going to pay for certain things to reduce your maintenance burden, that you kind of throw a lot their way. I mean, with the wheel rail interface strategy, you could throw a lot towards the client and try and get them to pay for things to reduce your maintenance burden. I don't know if that's true or not, but
I guess potentially there's it is worth sort of saying at this point we have a very, very good working relationship with the client. Our fellow engineers on the client side at DLR, we work very closely with them day in, day out on all sorts of issues, whether it's reviewing the issues of the trimetallic zone failures or ride quality things or indeed things around the wheel rail interface. So we never really have a conflict as such. One of the things that we're required to do as part of the maintenance is support the TfL capital renewals plan. In part they're reliant on us telling them where the issues are, where assets are becoming life expired, and that actually works quite well. And they come on site with us, and I think the important thing is there's no surprises. We're very sort of open on both sides in terms of what it is, and that tends to mean that we don't have any issues of conflict, and it works well.
Yeah, that's great. Yeah, sounds like it's a good relationship. Yeah, that's what it needs, and that will get you renewal to the contract at the end of the term as well. I would imagine that sort of thing. It would all help. So,
okay. Well, fingers crossed,
yeah.
Phil.
Yeah, is it next year? I think you said, isn't it? That's the contract finishes.
That's right. Yes. Yeah.
Yeah. Okay. Is there any more questions? Anybody else got anything else they want to ask? No, I can't see anybody. Nobody's putting it. Paul. I think Paul's got a question. Yeah, fire away, Paul.
Apologies, it's not a question so much as an answer, which I also put in the chat, just to the question about DLR apprenticeships. TfL is currently recruiting for 26 different apprenticeship schemes right now. For 2024 September starts, so not DLR, but lots of wider TfL opportunities if you know anyone who's looking for one of those. So I hope that's helpful to someone.
Okay, great stuff. All right then. Well, Jonathan and Tom, thanks very much for coming along today and spending the time to prepare the slides and the time today to present them. It's much appreciated, really interesting. You've covered a lot of ground. on a unique railway. It's DLR is a proper metro railway, isn't it? But kind of runs on tram design infrastructure in places, such tight radius curves, etc. It is a very unique railway with its own unique set of problems, I'm sure. So it's very interesting to hear about that. Something different for people who are not working on DLR, to learn more about PWI on other railways, other rail systems, and general infrastructure. So thanks very much for coming along. Much appreciated, both coming today. Thanks to everybody else for dialing in as well. Thanks very much.